Yeah, so if you are given a question like this and you are told that a curve with equation y equals to e to 2x sin x plus 3 cos x has a stationary point in the interval 0, x is greater than or equal to 0 and less than or equal to pi. And we're supposed to find the coordinate of this point correct to two decimal places. So these are just two questions, and there is another part whereby you are supposed to determine whether the stationary point is maximum or minimum. So to begin this particular question here, we are going to focus ourselves and try to see which is the best um, technique you can be able to use in order to differentiate this function that we have at this particular point. Now, I will start by writing the equation the way it was given. Yeah, let us try to write the equation the way it was given, and we are saying this equation was given as y equals to e to 2x into there is sin x plus cos x. So you ought to decide the technique you can be able to use. You can be able to differentiate using power rule. At the same time, you can be able to use quotient rule if you have two functions which are divided together. You can also use product rule if two functions are multiplied together. So if you can be able to look at whatever we are given at this particular point, you realize and appreciate that in this function that we have here, you cannot be there's no fraction divided, so we have e to 2x multiplied to sin x plus 3 cos x. Yeah, so this is actually plus 3 cos x, so meaning we are going to employ product rule in order to work out this. Remember, if you're having two functions multiplied, so in order to find dd of x of u v, whereby u is and v are the two functions which are multiplied together, we can be able to say, in order to work out this, it will be u dv dx plus v du dx. So this is telling me that in the process of working out this question, I'm going to differentiate each of the bank equation separately, and then I'm going to multiply to one of the function. So we can decide and say this one here, this that we have here, represent our u, and then we can say the whole of this function is going to represent our v. Now, since I need the v dx and I also need the u dx, I need to go ahead and find the u dx. So the u dx of this particular function is going to be 2e to 2x, because when you differentiate e to 2x, you are going to differentiate the top part and then you bring it down and maintain the function of the exponent the way it was. Then we are going also to differentiate the other one that we are having here, which is our v. So dv dx is going to be equal to what? So we are having two functions, sin x and 3 cos x. So meaning if we differentiate the first one, it is going to be cos x, and the other one, if you differentiate cos, you get negative sign, so this is going to be minus 3 sin x. Now once we have gotten all this, we can now go ahead and try to use product rule, and then we now plug in what we have. So dv, you can say dy dx is going to be equal to u dv dx. Our u is e to 2x, then dv dx is this part that we had gotten here, and this is going to be cos x minus 3 sin x. Then we are going to add, according to the product rule, v, we had said our v is this function, so it's going to be sin x plus 3 cos x, then times du dx, and our du dx is this part, so we are going to say this is going to be times 2e to 2x. So if I'm having this equation like this, I can see I can be able to say, remember we are talking of a stationary point is in the interval. We are supposed to find the x coordinate of this stationary point. So we can say at the stationary point, there's something we know about it. And what is that? We know that dy dx is equal to 0 at the stationary point. So that means in order to proceed from here, we are going to say now the whole of this part that we have can be equated to 0. And this is going to be, I'll factor out e to x, e to 2x. I'll have cos x minus 3 sin x plus, this 2 is going to multiply inside here because I've factored out, and that's going to be 2 sin x plus 6 cos x is equal to 0. So at this given point, if you can open your eyes widely, you can see we have cos x plus cos x, which is going to give us 7 cos x. And this minus 3 sin x plus 2 sin x is going to simplify. So in this part, before we move there, we can see now, since this is equated to 0, it means that either 2x is equal to 0, e to 2x is equal to 0, or, okay, let me just simplify this further. It will be cos x, that is going to be 7 cos x, and 3 sin x, negative 3 sin x plus 2 sin x, that's going to be negative sin x, is equal to 0. And now that will mean that this part equals to 0, or this part is equals to 0. But remember, um, there's no number you can be able to find exponent to give you 0 under this part. So we can tentatively say there and confidently that for this part, no solution. No solution for this part. So we are going to do away with it. You cannot continue with that. So the only part that will be remaining is this part here that says 7 cos x minus sin x is 0. And that means that this can be, we can take this guy on the other side of the equal sign, and we say that if you take a number over the equal sign, or under the equal sign, or through this space between the equal sign, the sign must change. And this is going to be cos x equals to sin x. Now, in order to proceed, we can now say this is the same as divide by cos x divided by cos x, which will mean that this term and this term will cancel out. We end up remaining with tan x equals to 7. So meaning this guy that we have in here, sin x over cos x, is actually tan x. And then we can now say at this given point that since tan x equals to 7, and in this particular question we are trying to find the x value, or the x coordinate, our x is going to be tan inverse of 7, and this is going to be 1.43 as our final answer. Now, the next part of this question, what we are expected to do is to determine whether the stationary point is a maximum or a minimum. So in that kind of scenario, you need to understand, for you to state whether a function is a stationary point, the stationary point is either maximum or minimum. Now for part B, we can find again, since we have obtained dy dx is equals to, since we have obtained that our dy dx is equals to e to 2x into bracket 7 cos x minus sin x. So that will mean that you need to differentiate this for the second time. So if you differentiate this for the second time, you are going to say that this is going to be d squared y dx squared is going to be equal to, we are going to apply again power rule, rather product rule, in order to differentiate this. So we can decide to keep the first one constant 2x and then differentiate this part. So this is going to be negative 7 sin x minus cos x, and then we can also say now this is going to be plus, we differentiate the exponent keeping the other term constant, so this is going to be 7 into bracket, differentiate this one is going to be 2 exponent x, 2 exponent, so we differentiate the top, we bring it down, it's going to be 2, then exponent 2x into 7 cos x minus sin x. So if you are going to work out this question, you're going to realize that we shall have then d squared. The next thing you're going to do is dx squared. You try to substitute to this function the value x equals to 1.43, so that you can be able to see, are you getting a positive value or are you getting the negative value. So that will mean that if you substitute here, you are going to get that the answer you are going to get is actually a negative, which will be equal to a negative. So meaning that d, meaning that our d, okay, let me just try to find somewhere to write. So once you work out that, you are going to realize that our dy dx squared, d squared y dx squared is less than 0, and when you get that is less than 0, that means that this is a maximum point, going to be a maximum point. So that's basically what you do in a scenario like that. So maybe what I can do, I'll quickly take you through another question that you may um, be given. So a question that uses a different technique, so that we can see also how to perform that kind of question of differentiation. So in this question number 2, we are basically going to use quotient rule, because we are given cos x, we are given cos x, f of x is actually cos x over 1 plus sin x. Show that f is less than 0 for all values in of x in the interval negative a half pi, x is greater than negative a half pi or less than 2 over 3 pi. Okay, now since we are told that a function, our function that we are interested with, f of x is cos x over 1 plus sin x. So this will mean that the rule that we're going to use here, we are going to use quotient rule. We're going to apply quotient rule in this particular question. So how do we, how does quotient rule state? Quotient rule states that if you have, if you are finding d of dx of two functions which are divided like that, then it means that you are going to say v du dx minus u dv dx, then divide by the v squared. So under this equation, we can say now let our u be equals to cos x, and our v is going to be 1 plus sin x. So as we did the previous section question, since we are going to use dv dx and we are going to use du dx, we can decide and at this first step to find du dx, and this is going to translate to sine negative sine x. Also, if you find dv dx, this is going to translate to cos x, because if you differentiate this first term, it will be 0, and differentiating the second term, which is sine, is going to give you a cosine. Then now we can now say our f prime, or the differential function to this, is going to be v. Our v is actually this guy that we have here, and then we're going to say 1 plus sine x into bracket du dx. So we are going to multiply to du dx, and our du dx is negative sine x, then minus our function u, which is actually cos x, times, and that's going to be multiplied to dv dx, and our dv dx is cos x, so this is cos x. Then we shall divide all through by v squared, and our v is 1 plus sine x, and then we're gonna square that. So, but the main question is, show that f prime, the differential function, the derivative f of x, is less than for all values of x. So we ought maybe to try to manipulate this for quite some more time, and have this as f of x prime of x. So this is going to translate to, if I try to open the bracket, I'm going to get 1, this is actually going to run to, this time this is going to become negative sine x, and then if I multiply here, I'm going to have negative sine squared x, minus, if I multiply here, I'm going to get cos squared x. That will mean when I have this below, it will mean that this is going to be 1 plus 2. Okay, I no need for that. I can say 1 plus sine squared x, rather no, we shall have 1 plus sine x squared. So I want you to look at whatever we have here, because we can be able to factor out the negative sign, and our function beautifully becomes negative sine x minus into bracket sine squared x plus cos squared x, and that is going to be divided by 1 plus sine squared x. No, that's an international crisis, so that's squared like that. Now we know that in the world of mathematics, that whatever we have at this part is going basically to run to 1, right? It's going to run to 1, and the all of this, I mean, is going to run to 1, and that means we shall have minus our f prime is going to be equal to minus sine x minus sine x minus 1 over 1 plus sine x squared, which will mean that this can be written as negative 1 into bracket 1 plus sine x over 1 plus sine square and sine x then squared. So you see, whatever we are having at that given point, basically this if we cancel this, okay, for those who are not seeing what I'm seeing, we are going to say this is going to be into 1 plus sine x over 1 plus sine x into 1 plus sine x, and then at this given point the two will cancel out, and we eventually remain having f of x equals to negative 1 plus sine x, that point. So for all values of x, since this function is having a negative here, for all values of x, this is going to be negative. So f of x is actually going to be less than 0. It's going to be negative because we are having that negative at that particular point. A curve of the equation a curve has the equation y equals to cos x sine 2x. Find the x coordinate of the stationary point in the interval 0 x is greater than 0 less than or equal to half pi. So that given point, we are going to write the equation the way it is. We are told y is equals to cos x sine 2x, and that is the equation. Now we're supposed to find the stationary point. We have said that this at the stationary point the y dx is actually 0, so we are going to differentiate this, and we shall use actually product rule because we are having two functions multiplied together at that point. So we can say our u is going to be equal to cos x, and then we shall say our v is equals to sine 2x. Then since we are going to use product rule, you remember that we need to find du dx. So this is going to be du dx is actually going to be minus sine x, and dv dx is going to be, now we are going to use chain rule at this point because this is a function of x and the sine is also a function of x. So that will mean that we shall differentiate the inner function first. We are going to remain with 2, and then we shall multiply that to the differential of this without looking at the inner function, and that's going to be cos 2x. So that is what we are going to get, and that means we can be able now to say product rule product rule. So if you have finding d of dx of two functions multiplied together, we are going to say is the first function u dv dx plus v du dx. So once we have that, we can basically we can now substitute the function that we were having at this point. So this is going to be dy dx is going to be equal to what? Our dy dx is going to be u, our u is this, so it will be cos x times dv dx. dv dx is actually 2 cos 2x, then plus what? Plus v, our v is sine 2x times du dx, and our du dx is negative sine of x. So the only thing that we have at this particular point is to go ahead now, try to simplify and put things in order, and that's going to be 2 cos 2x minus 2 sine. Okay, no, I think I'm just jumping the gun at this point. So this is going to be 2 cos x cos 2x, and then minus, we are going to subtract sine x sine 2x. So finding the station point, and at this point we cannot be able to work anything out here without, okay, we can now say at the stationary point, at the stationary point at the stationary point, dy dx is equals to 0. So we are doing that so that we can be able to take whatever we have equated to whatever we have gotten here as our dy dx, we equate that part to 0, and we shall see now this is true. Cos x cos 2x is going to be equivalent to sin x sin 2x. So what I was saying, this kind of an equation, you cannot be able to really work it out because you are having double angle at this point, and also you are having double angle at that particular point. So it's upon us to see how can we be able to try out and work it out in order to remove those double angle. But remember, this double angle here means that um, this is the same as 2 cos x. So this part that we have here can be written as sine. We can write it in terms of sine. Okay, we can write it in terms of cos squared x minus sine squared x. Yeah, can write that in that manner. Is going to be equal to sine x, and this term that we are having at this point can be written as 2 cos x sin x, or 2 sin x cos x. So at this point you can see I can divide also by these 2 cos x, and I can also divide here 2 cos x. Now at that given point I'll have all the right reserved according to the laws of maths, that I can be able to cancel these guys like that, and we end up having a very beautiful equation which we can be able to write at this given point and say this is going to be sine squared x minus, okay, let me just change this. This is going to be cos squared x minus sine squared x, cos squared x minus sine squared x is going to be equal to this, and this is going to give us actually sine squared x, and that means we can be able to take this on the other side of the equal sign and end up having cos squared x is equals to 2 sine squared x. So at this given point I can decide to divide by 2 cos squared x divided by 2 cos squared x. Now the reason as to why I've actually done that is to ensure that I can be able to cancel cos and cos, 2 and 2, and I will remain with tan squared x, because sine squared x over cos squared x is actually going to be tan squared x, which is going to be 1 over 2, and that 2 is going to be coming from this given point, and then which will mean that I can be able to find the square root and the square root, and then I remain with tan x is equals to 1 over root 2. So if I'm finding the x coordinate, and I need to find the tan inverse of this part, so which will mean that this is going to be, our x is going to be tan inverse of 1 over root 2. And if I use and consult my calculator, I'm asking it, you guy, what is the tan inverse of 1 over root 2? And the answer I'm getting is actually 0.6154, and we're supposed to give our answer correct to three significant figures. So that means the answer you are going to write is 0.61, 0.615, 0.615, 0.615. And now that becomes the x coordinate of the stationary point. In the previous video and the previous part, we have dealt how to differentiate questions like these ones. We did question 3, how question 2, how to use quotient rule. At this point, the question 1, we are supposed to use product rule, and then we also learned how to find the stationary point and determine whether the stationary point is a maximum or a minimum. Remember, we say that if you find the derivative of that function and you find the second derivative of the function, it will mean that if d squared y dx squared is greater than 0, it means that's the minimum point. If you get a negative number, it means that's the maximum point. Here we used quotient rule in order to work out this. You can check in the previous video if you have not watched that. At this point also, we differentiated using product rule and then worked out the x coordinate of the stationary point. Now this brings us to question number 4, whereby we're going to focus on how to obtain the expression for dy dx, show that this can be written in the form x squared x a plus b sine 2x into x e to negative 4x, where a and b are actually constants. So when we look at the original expression given, original equation given, we just notice that this is a product of two functions. So meaning we are going to use product rule in order to work it out. So let us go straight ahead and try to work out this question. And we shall begin by writing how the function was given. The function was given y equals to, the function is given as y equals to e to negative 4x, and then we have tan x. So we shall start by saying that our u in this is e to negative 4x, and our v in this case is tan x. Because when we're going to apply product rule, we are going to make use of dv, and actually we are going to make use of du. So it's wise at that point that we can be able to find our du dx. Du dx is going to be equal to, when you are differentiating exponential functions, what you do, you differentiate the top and you get the answer. And differentiating 4x, negative 4x, we're going to get negative 4. Then you write the exponential function the way it was given. That is how you differentiate this kind of exponent. And when we are differentiating tan, if you look at tan, if you differentiate tan, we are going to get dv dx equals to sec squared x. Now, product rule states that if you have two functions multiplied together, like for instance, we have u multiplied to v, then the answer to this is going to be u dv dx plus v, then du dx. So that could mean that we can be able to substitute what we have here, and then because already we have done the big part of it of differentiating, so meaning that we can write this is our u is actually e to negative 4x, so that's e negative 4x times dv. Our dv is this, which is sec squared x, then plus v du. So our v is tan x, and we had gotten our du dx, which is this part, and that's going to be actually times negative 4e to negative 4x. Now, remember, you have to look at the way the expression was actually given. The expression was supposed to be given in the form of sec squared x into a plus sine 2x. So at that given point, we can try to see what can we manipulate at this point in order to have that. So I can be able to factor out. Okay, before I factor out, I need to appreciate the fact that tan x. How can we write tan x? Tan x is actually tan x can be written as sine x over cos x, but I'm targeting to have two sine. I'm targeting to have sine 2x. So for me to get sine 2x, I need to have cos x here. Then since I've introduced cos there, I'll also say cos x, because that effect now has nothing. So which means that this tan x can be given as sine x cos x is equivalent to what? Is equivalent to sine x cos x over cos squared x. And this means we can say this is sine x cos x times sec squared x, because 1 over cos squared x is actually sec squared x. So we can now replace whatever that we have gotten at this point. We just put it at this level here. And I will just start by saying this can be written as e to negative 4x sec squared x. I need to write this properly so that it can be feasible. This is sec squared x. Then this will be minus 2 times, because we are having 4 here, so I'm going to say it's 2 times 2, but I need now to write that sine x cos x, then I have exponent, okay, sine x cos x, then sec squared x, then I have my exponent negative 4x. So what I've just done here, I've replaced tan x with whatever we had gotten in this side after showing here. But because I need to have sine 2x somewhere, but I decided now to split the 4 that we have, so that it's in its 2 factors, 2 times 2, which is going to give us 4. And we are going to appreciate the fact that this part that we have here is actually equivalent to sine 2x. So that's the main reason as to why I did all these shenanigans, and then I can be able to plug it in. So our equation therefore can be given as exponent minus 4x sine square, no, this is a sec. This is sec squared x minus 2 sine 2x. Now we are saying this part that we are having here can be replaced with this, and then we have our sec squared x exponent negative 4x. Now, at this given point, we can now start factoring things out so that we can be able to give the equation in the form it was expected at this particular point here. And then we can now say we can factor out sec squared x. This is going to be sec squared x into bracket 1 minus 2 sine 2x, because on the other side I'm going to factor out exponent negative 4x, and that is now the form that we are supposed to give our answer in. Now, at this given point, we need to go straight and try to see the next question, because you are supposed to now, hence, you are supposed to find the stationary point for that. Already we have gotten our expression for the derivative, or dy dx is this one. Then now we can be able to go ahead and find the stationary point for x. So I'll just leave this part that we have gotten down here, and we are going to say now that since our dy dx is equal to sec squared x into 1 minus 2 sine 2x exponent negative 4x is equal to 0 at the stationary point. So we can now say we can, at stationary point, dy dx of a function is usually equal to 0. So at that point, we can be able to conclude and say definitely this is going to be sec squared x into 1 minus 2 sine 2x exponent negative 4x is equals to 0. So at this given point, we have all the right result to us and say that we have three parts of this equation, and therefore we can be able to say the first part, which is sine sec squared x, can be equal to 0. So we can say the first equation, sec squared x, can be equal to 0. We can also say 1 minus, okay, let me just leave that one there. I write exponent minus 4x is equals to 0, and we also can say minus 1 minus 2 sine 2x is also equal to 0. So if you can look at this part that we have at this point, actually sec squared is can be written as 1 over cos squared x. That is how sec, what sec means, is equals to 0. So in order to find the reciprocal, we are going to get at a point whereby we are saying that um, if we find the reciprocal, this is going to be cos. Okay, at this point we can say there's no number. You can be able to divide 1 by in order to get 0. So we can say here there is no solution, no solution, no solution, because there's no number where you can say 1 divided by that number to get this. So at this point, we can say we are not going to continue with that. And this one here, there's no number you can be able to raise by an exponent in order to get 0 as well. So at this point also, we say no solution. So we are going to be left with one option, whereby we are going to go ahead and try to use this one in order to get the value of x, because we are finding the exact x coordinate, and that's going to be 1 is equals to, by taking this on the other side, we shall have 2 sine 2x, and this means 2 sine 2x is actually equal to 1, whereby we are going to divide by 2, and we end up having sine 2x is equals to a half. Now, but remember, x value was given in the range from 0. Let's try to check the way the range was given. Was given from x is we were given x is greater than or equal to 0, less than or equal to a half pi, a half pi. So having given that, and if you look at the equation the way we have it at this given point here, you notice that we are having 2x at this point, and yet here we are having 2x, but here we are having x. So meaning we can now increase the domain of x by multiplying by 2, and then the new domain is going to be 2x is greater than or equal to 0, less than or equal to pi. So whenever we are going to solve our angle, we are going to work it within this particular domain. And so we are going to say this is going to be 2x is equal to the sine inverse of 1 over 2, and that is going to be, actually, if we can be able to use our calculator, and remember your calculator has to be in radians. I'm getting 1 over 6 pi. I'm getting 1 over 6 pi. So we need to find, remember at this point, this is sine 2x equals to 2, so is equals to a half. So meaning we are finding where sine is positive. So it will mean that all students trust Cambridge, but our angle that we have gotten is actually 1 over 6 pi. And then it means for at which quadrant do we have again sine being positive? That is also in the second quadrant. So which means that we can be able to find that angle also in the second quadrant. But if this is 1 over 6, because of uh, this angle is 1 over 6, this is going to be also 1 over 6 pi. But since we were finding positive angles, then the next angle we are going to find is this angle that runs up to this given point. Now, to get the angle at this given point, it will be pi minus 1 over 6 pi. So the second angle, so we have said that our first angle is 2x equals to 1 over 6 pi. And the second angle would be 2x is equals to pi minus 1 over 6 pi, which is coming from this given point here. And then definitely at this given point, we're going to get 2x is equals to 5 over 6 pi. And at this given point now, for us to get x, we are going to divide this by 2, divide by 2, and also we are going to divide this by 2, so that we are going to have this as 1 over 12 pi, and this other one is going to become x is equals to 5 over 12 pi. So those are the two, and I think it's not really clear down here, especially this part. I need to write it somewhere you can be able to see. So here it's going to be 2x equals to 5 over 6 pi. Now to get x, we are going to divide this by 2, and then we are going to get our answer being 5 over 6, rather, we are going to get our answer here 5 over 12 pi. So those are the two solutions you are expected to get in this particular question. Now this also brings us to the next question of interest. Now, the next question of interest is the question whereby you are going to differentiate tan squared. And just look at that. Question 5, the equation of the curve is given by y equals to e to negative 5x tan squared x. So how are we going to approach this particular question at this given point? So meaning at this point, we are going to again use product rule, because we can see that we are given y equals to e to negative 5x tan squared x, which will mean that our u is going to be e to negative 5x, and our v is going to be tan squared x. So how do you differentiate? Because we're going to use product rule, and the reason is these are two functions multiplied. So we are going to say our du dx is going to be negative 5 e to negative 5x. We said if you are differentiating an exponent, you differentiate the top, you bring it behind the exponent, and then you write the exponent the way it was given. Then we also have to find the v dx, which is going to be equivalent to okay, so this one, it can be written as tan x then squared. Now we are going to have or we are going to make use of chain rule at this point because there is a power. We are going to differentiate using power rule and just assume this function inside and say this is going to reduce we take the power down and we maintain the function inside the bracket the way it is. Of course, when we take the power down, we're going to decrease the power by 1, and that's going to be actually 1 at the top. Now, once you have done that, now you go to the inner function. You again differentiate it without looking at the power, and that's going to be sec squared x. So, using product rule, we know that product rule is uv is actually u dv dx plus v du dx. So that will mean that our u is actually this one. So, and that's going to be negative 5x times our dv dx, which is going to be 2 tan x sec squared x. Then we are going to say plus v, our v is actually tan squared x, and our du dx is this part, which is times negative 5 e to negative 5x. So this is going to simplify to 2 e negative 5x tan x sec squared x minus 5 e to negative 5x tan squared x. So because in this question we were just supposed to differentiate and get the derivative dy dx. So this is our final dy dx. Maybe if we are supposed to factorize out things and to make the examiner happy, we can just say this can be written as what? This can be written as a okay, we can see there's tan x, there's also tan x here. We can be able to say this can be written as tan x e to negative 5x to sec squared x minus 5 tan x. So of course this step is just to try to make things cleaner, but it's not really necessary because you are not told in the form you are going to leave your answer. So basically that's what you are supposed to do whenever you are doing differentiation in math 3, that is P3. You need to understand how to use quotient rule, how to use product rule, how to differentiate exponential functions. You need also to know how to differentiate trigonometric functions. So this is not all, but this is just some of the part that you ought to know, because whenever you are going to do an exam, you'll be expected to do differentiation. So some of those basic knowledge of differentiation is required, especially differentiating exponents, differentiating polynomials, differentiating trigonometric functions is highly required, because you cannot be able to proceed to solve an application question like those that you are told to find the minimum point or the stationary point if you really don't know that. So as you are preparing for your exam, make sure you have all those basics, and then now you must immerse yourself into past papers in order to know and try to have a feeling how are question asked and how do you approach them. So in the next series, we're going to do and see how do you do parametric differentiation, because in this course also there's another technique you can be able to learn on how to and stick in Proplan YouTube channel, so that whenever I'm going to upload that particular part, you'll be notified. We are going to have a series that's going to run through all the topics that you are expected to learn. So this is the beginning, and I believe you'll have a reason as to why you ought to subscribe, so that whenever we are going to upload more tutorials, you'll be notified.